What the hell?
Our hypothesis for the lab is the heavier the potato, the slower the muzzle velocity, but the higher the ballistic pendulum will go. This means that the fastest potato may not be the one that pushes the ballistic pendulum the highest. We believe that this is the case because the heavier potato will have more momentum. For our independent variable, this will be our potato mass. We will have 3 groups of potatoes, a 100 gram as the control, a 50 gram as the small group, and a 200 gram as the large group. Our dependent variable will be the muzzle velocity, horizontal and vertical displacements of the ballistic pendulum. These values will be different based on the potatoes used.
In this experiment, we calculated the horizontal displacement of the bucket after we shot the potato into it, and then afterwards,
using Co and Cop, specifically MA plus MB, VB, that thing, the inelastic collision, perfectly inelastic, we are able to calculate the initial velocity of our potato. We have 3 potato types here. We have the 100 gram potato, which is our control potato. Then we have the 50 gram potato, which is the small potato, and the 200 gram potato, which is the large potato. We will use that and then calculate the momentum of them and see how high each one of them will push the bucket. Things that will keep constant is distance of the potato cannon to the barrel, to the bucket, and the amount of spray used in each potato shell. That's it.
Got recalled.
How high did that go?
So, after we get all of our data on the field right here, I take averages of the 3 masses for the 3 trials, the controlled trial, which is roughly 100 grams, the large trial, which is roughly 200 grams, and the small trial, which is roughly 50 grams. So, then from there, I again average out the horizontal displacement that the bucket made from each shot. From there, using the Pythagorean theorem, I'm able to calculate how high it went. 1.3, which is the radius length of the rope, square root of 1.3 squared minus delta x horizontal displacement squared, square root of that, would find this value right here, and then I can then calculate from there. Once I have that value, I find the delta y of every value, so how high vertical displacement. From there, using this derivation, velocity is equal to square root of 2 times gh, gravity and the vertical displacement. I'm now able to calculate the height, the velocity from the height. So here's the control trial, the large trial, and the small trial for each of their respective velocities. Then, using conservation of momentum and this equation, the perfectly inelastic equation, I have initial mass of the potato and initial velocity of the potato plus the initial velocity of the bucket and initial mass of the bucket is equal to the masses of the bucket plus the potato and the final speed of the bucket, or the final speed of the bucket. This can cancel out to 0 because its original velocity is going to be 0. And then using our 3 equations right here, I calculated out that the trial, which is the 100 gram potato, has a velocity of 34.288 meters per second. The large potato has a 22.36945 meters per second, and the small potato is 25.11758 meters per second. And this matches my hypothesis perfectly. My hypothesis was that with all the variables except projectile weight held constant, the heavier the projectile, the higher the ballistic pendulum will rise. The fastest projectile may not be the one that pushes it to the highest. And that is all for the calculations, and now I'll play some videos of us shooting the cannons for fun. Continuing on what we had earlier with the control, large and small potatoes, I find the acceleration velocity squared over 2 times the displacement. So 925.7 meters per second squared for control, 394.73 meters per second squared for large, and 496.78 meters per second squared for the small. Then we repeat the masses again, and here we calculate the time in the barrel. So 0.037 seconds for the control, 0.0567 seconds for the large, and 0.0505 seconds for the small. With that, the time, I can calculate the average force exerted on the potato by the barrel, or the combustion behind in the barrel. So 95 newtons for the control, 78.64 newtons for the large, and 25.2 newtons for the small. So because the large potato, even though it has a higher momentum, it spent more time in the barrel, so this is lower. And this was the formula I used. That's the average force formula. Then I calculated the momentum of the potatoes. So the control potato had a 3.497 kjm over s. The large had a 4.46 kjm over s. And the small had a 1.2726 kjm over s. And this confirms my hypothesis that the largest potato, while not being the fastest, still had the most momentum and was thus able to push the bucket the highest.